Okay, folks. So here's what we're gonna try to do today. I'm really curious about this whole coronavirus situation, and I figured I should make a data visualization about this. It's been a really long time since I've done any data visualizations and streamed them. So now this seems like a good excuse to try that. Oh, now you're probably gonna hear me better. So I figured there's already a lot of data visualization about the coronavirus out there. There's a bunch of charts, a bunch of different graphics, a bunch of geospatial visualizations, a bunch of comparisons between the US and Italy and all the different countries. So none of that seemed like something interesting to do. I was like, okay, we can probably find the data sets, we can analyze them, and we're gonna end up with something that's pretty much the same as what every journalist has already done. So what I'm gonna try to do instead is create an interactive simulation of how viruses spread, so that we can compare different factors between the virality of a virus. So we can compare flu versus coronavirus. We can compare what happens with social distancing, without social distancing, and stuff like that. So I made a couple of sketches on what I'm going to try to achieve, and it's basically going to be relatively simple, but I think it's going to have a powerful communicative something. I don't know how to pronounce words. So basically we're going to make a visualization of a population with dots, and we're going to make a random dot infected, and then we're going to iterate over the dots are going to move around, and they're going to be spaced at different intervals, and we're going to try to see how an infection spreads through the population and what happens. Hey Miha, how are you doing today? So that's the goal. That's what I'm going to try to do. I started a new Create React app so that we can have this in a separate app. I called it the Corona Simulation, and I'm going to also git init this, git status, git at dot, git commit -m. Let's say initialize with CRA. And then we're going to start this and open the project and get started. Terminal wants to access. Why does the terminal need to do that? Oh, that's why. So open the project is in Corona Simulation. We have the basic create React app page here, and I'm gonna put it up on GitHub later. I don't want to do that right now. So we're gonna start with first cleaning up the Create React app stuff, and I'm gonna add D3 because I'm pretty sure I'm gonna need D3. And then we're gonna start with, I should probably put this somewhere. So how can, I'm running out of screens, but basically this is what we're trying to do. So I'm gonna put this over here somewhere so that it's gonna be in the way wherever I put it. Let's see, what can we do? Let's add yarn add D3, and I'm gonna open the app.js file, and we're going to start messing with things here. Probably also don't really need app CSS. So logo is being used or not, and we can add an H1 here that says visualizing the spread of viruses in a population. And please let me know if my music is too loud or you can't hear me very well. And I'm also going to be observing the chat room, so if anyone says hi, hey Magdi, I'm going to try to say hi back and ask questions as we go, or give me suggestions, because I don't know what I'm doing. So we're going to start with an SVG, because I know SVGs are good for this sort of thing. Let's make an SVG with SVG. Let's give it a style that takes up the whole screen. We can deal with this and make it better later. So we say width is 100. Is it like that? Fuck, why do I keep forgetting this stuff? And height 100 VH. I think that's gonna make it full screen. It's been a while since I did raw CSS, so I'm a little rusty. I've been using Rebase a lot lately. Let's give it a border of 1 pixel solid red so that we know where it is. Cool, that works. We can fix this later and make it better. And then inside, let's start with, hey Candy Cane, how are you doing today? Back in the rat race. So we're going to start with, let's make a little app, let's start with a very simple component that tells us what like a person in a population. So let's say population, and let's call it a person. So it's a person, and each person is going to have an X. Let's put this dude at 100, 100, and let's make a new person. I'm just going to define it here for now, then we're going to refactor later. So each person gets an X and a Y, and it's going to return for starters a circle, and that circle is going to be positioned at X, and CY is going to be at Y, and let's give it a radius of 5. So that should make a circle show up. It did. Yeah. Magdi says that he just discovered Tailwind and it's amazing, and I agree. I haven't used it yet, but I've heard a lot of really good things about it. So we have a person. Let's make sure that this person can be, let's see, what's the next step? We need to have a color based on whether the person is normal, infected, or dead. Yeah, we should dead or recovered. Should we have recovered as well? We should probably have recovered. So we are going to say that each person is going to have a state. God damn it. It would be nice if Create React App supported what's it called? TypeScript, but it doesn't. So we're going to have dead. Yeah, let's have dead. No, infected, dead, recovered. Infected, dead, recovered. These are going to be booleans, and then the color is going to be, let's say that the fill is always white. So this is going to make the circle go back to white, and then it's going to have a border. Actually, let's use the style for this style. And let's say, so fill is white, and then border is, oh fuck, what is it? Border radius? No, because this is SVG. Make a try of next. Yeah, Magdi says I should try next, and he's right. But I'm using Create React App right now, and it's been a while. So we need to, how do you style? Why did I forget how to style SVG? This is kind of embarrassing. So I'm gonna go here and say we have does border 1 pix solid red work? No, it doesn't, because it is, oh, it's stroke. So we have stroke 1 pix stroke red. There we go. And we have stroke width. Let's keep stroke width as 1 for now. So stroke is going to be, oh, nice. I've gotten 100 messages today. That's weird. Next 9 comes with TS. That's awesome. So the stroke for this one is going to be, let's see. How do we get the color? If you are infected, let's say stroke color here, and stroke width is going to be 2. So now we need to define the stroke color, return the person, like that, and we say const stroke color. So stroke color equals let stroke color. The default stroke color is going to be what I had in my sketch, because why not? How do I get these colors actually? That seems difficult. Is there a color picker that I can use in? Does anyone know how to get a color picker? Online color picker. Okay, now I need to get an image up here, right? Yes, image color picker. How do I upload my image? Come on, upload my image. Why is this so slow? Upload my image, which is in documents. No, it's in downloads. We get this thing. So we get the color, which is this. So stroke color starts as that. And then if infected, then the stroke color becomes this other thing. So I'm gonna copy this part. Oh, I have a copy function. Cool. So that else if dead, then the stroke color is, what's a good stroke color for somebody who's dead? Should we just make it black? Black. Let's make it RGBA 000, and we're gonna say 0.5, so it looks more gray than black. And this is where I should really have used, oh, there's a color picker in the DevTools. I had no idea. And if you are recovered, then your stroke color should be, let's say, you're back to normal, right, when you're recovered. So we can have this for now. I really should have used styled components. Okay. Yeah, Slovenia is next to Italy, which is kind of like New China, you're right. React app, so we have that. Cool. We have the person, and now if we say the person is dead, that circle turns gray. Let me zoom this in a little bit for now. If we say they are infected, it turns red. And if we say recovered, it goes back to normal, right? Perfect. I really should have used styled components, but okay. So we've got that part. When they're red, should the fill color be red as well? Yes. Let's make it so. Let fill equals white. And then if you're infected, fill color becomes this as well. Fill color. And that's gonna be so that the, hey Max Joet, how are you doing today? So now if we say this person is infected, we get the thing. Cool. Awesome. So we have a way to render a single person. Git status, git commit -m component for single person in the population. Now we need to render a bunch of people in a population. So how do we do that? We should make it, let's see if, first I'm gonna check if D3 has a layout that might help us with this, because I don't wanna build it from scratch, because that's kind of like a CS problem and we're trying to do something else today. So D3, let's see, D3 layouts. Do they have any cool layouts that we can use? Layouts, chords, forces, force layout could be useful, but no. Okay, now this could be cool. Let's see, how does this work? This could be a good way to put things around, but I think it's going to have a problem. So these still need to be connected, so that I don't think that's going to work. We can also physics engine, yeah. So force layouts are all very good, but I think that's going to be it's not going to be what we need. Hierarchies, this is not a hierarchy. Quadtrees, we can use Quadtrees for collision detection. So we're going to use Quadtrees for this stuff so that we know how things are divided. So that's going to be useful. And what else can we use? Random numbers, scales, the quantized scales, modifying elements, shapes. Okay, So we're gonna just go with circles and let's try to lay them out ourselves. So the layout part is going to be probably the hardest part right now. So let's try to lay out a bunch of persons. Let's go with, how should we do this? We need to generate the data for them first. So let's say population.map. It gets on X, Y, and whether you're infected. So it's going to get, actually let's start with just getting X and Y. So X and Y, or P, and we render a person with P.X and P.Y. That now we need to get a population, const population equals, we can start with something manual. So X 100, Y 100, and then X 105 and Y 105. So this is just to get us started. So we get, this renders 2 circles, right? Okay. Perfect. 2 circles. Now let's generate a population where the circles are actually, so where we need to come up with a layout that looks a little bit like this. And we're going to start it like this, and then we're going to make every member of the population actually move. Do you ever have the urge to reformat and start fresh every couple of months? What do you mean by that, Max Joet? Like with your computer or like some other part? So let's, how do we generate? Let's generate a row first. So generate row of, let's say 1, 2, 3, 4, 5, 6, 7. Actually, no, let's call it generate population. Create population. So function create population that gets an n equals, let's say 7 for now. So we are going to create widest row first, then move up and down until n equals 0. So we're going to basically create a population somewhat recursively. So we return first, let's see, const row equals an array, and we say for let I equals 0, I less than n, I plus plus, we create a row.push, and we create a person who is at x of let's say I for now, and at y of 100. So this is going to create our first population, right? We need to return the row, and we should now get a row of these guys, but we need to use scales to make it spread out a little bit more. So we're going to create a population, and let's also give it an x and a y. So let's say this needs to be centered around 100, 100, and we say x, y, and n. Yes, x, y, and n. So then we create a scale. Let's see, import. Let's just do a simple D3 import so that we get everything at the same time from D3, which will make our life a little easier. And now let's see if there is a D3 scale that can do this for us automatically. So we get D3 scales. We're gonna need, should we take a continuous scale, sequential, diverging, quantize? I think an ordinal scale could be useful here, because an ordinal scale automatically places things for us, right? So it's going to place all of these yeah. So if we use a scale point, it's going to automatically tell us exactly the positions of every dot that we want to place. So point scale positions row for us. So we say const, let's say x equals x, let's say const x scale equals d3 scale point, where the domain scale point domain goes from, so we're mapping from a domain to a range. Domain goes from 0 to n, because we know we're going to iterate from 0 to the number of items we want to create, and the range is going to start at what do we want the width of these things to be? Let's go with first with 0 to 100. So we get the x scale, and now instead of pushing in the I, we push the x scale of I, and we should now get evenly spaced dots in theory. No? Each child in a list should have a unique key prop. That's true. Now why don't we, oh, we can also make this a little better. Let's return, let's say const row equals d3 range from 0 to n, and then we map over that, which gives us an index, and each of those needs to return stuff. Return row. So we are getting x should be x scale of I, and then y should be 100, so that they're all placed at 100, or let's say y should be y. And what am I missing? Another one of those. So these are not working. Why are my circles all at, they're all positioned at cx of nothing, which is not great. So something with the scale point is wrong. What can we do? Let's add a debugger here, debugger statement, and let's see what's going on. So x scale is a function. If we run x scale of 10, what happens? So n gives us that. What is x scale dot domain? Uncaught type error. What? Cannot read property domain of undefined. What about just x scale dot domain? So the domain goes from 0 to 7, which should be okay, and the range goes from 0 to 100. So that means that 0 should map to 0, 1 should map to something in the middle. So what am I missing here? Constructs a new point scale, given a value in the input domain, returns the corresponding point derived from the output range. Yes, so if we say x scale of 1, why is it returning undefined? That makes no sense. What? So the domain should be I am confused. So hey Olatoya, what are you up to today? So for some reason, why is this not working? What happens if, because I know I've done this before, but now it's just messing with me. So we're mapping from a domain to a range, which should be fine. Specify domain. What if we say x scale dot domain is 0,7 like that, and then x scale dot range is 0,100. Now we call it x scale of 1. It's still undefined. So what is x scale? It's a function. unknown, return range, implicit, yeah. Okay, let's try looking up a point scale example online, because what? D3 point scale example. I've done this so many times before and now it's just not working. So scale point, d3.scale point, we have that. Domain, oh, I'm an idiot. So here's what's gonna happen. This is an ordinal scale, which means we need to pass in every single number that we want to use as the domain, not just a range. So we need to say d3.range from 0 to n, and now I think it's gonna work. We can remove the debugger statement. Yes. Alright, so now we have all of these guys. Now we need to make sure that we're actually using the x as a center and the y as well. So we're going to say, if we go from, so what we need is to have a population that accepts a central point, so a cx and a cy, and we need to also define the maximum width that we want. Or does the width matter? Yes, it does. So create population. We're going to change this to be an object, and we say cx is going to be 100, cy is going to be 100, and then the width should be, let's give it a width of 200 pixels for now, and then a height of 200, so it needs to fit into that, and then we're going to actually calculate the n instead of passing it in. We say so cx, cy, width and height, and then we're going to calculate how many points we can fit into that. So if we have a width, so generates a population oriented around cx, cy, fits into width, height, into width and height. Got that part. Now, what did I delete here? Range goes. So we need to pass. We need to first. So candy cane, this won't really get to the millions. It's more like a smaller simulation, but we can always make the points themselves smaller. So with, yes, we lost the n parameter because we're going to calculate the n parameter. And in terms of millions, this won't work well with millions just because there's going to be too many data points on the screen to be rendered. So we can say const n equals, if we know that a human is 5 pixels wide, we can pass in width divided by 5, and we're going to math.floor this. So fit as many as possible into a row. So that's the n. This is going to be cy, and x scale is now going to go from cx minus width divided by 2 to cx plus width divided by 2. So we got a bunch of them. Cool. Math floor, why is width divided by 5 giving me the wrong result? And why is it not centered around the 100? What if we do this? Okay, so that's moving it. That's great. Let's put it at 500, or let's go with 400. Now, why are they need to have more padding? Yeah. Okay. So we have that, and let's give it more width. 400. So we now have a row of these guys. Now, so fits as many as possible into a row, and now we need to make this a what was I gonna say? what was I gonna say? Okay, I forgot where I was going. So we have this X scale. Now we need to recursively call this to create populations for each of the rows. So we're going to, we have the first row. So this creates a population row. And for the height, what do we do next? But we also don't want to really do it recursively. Do we? Yeah, we're trying to generate the other rows. I'm just trying to figure out if this should be an array of arrays or a flat array. Actually, a flat array is going to be easier, but we can generate it as an array of arrays first. So let's call this a population. No, let's call it a row. And then if we iterate, so const population is going to be an empty thing, then we go with d3.range. Yeah, it's actually gonna be easiest if we call it if we do it recursively. So this generates a population row. So now what we need to do is call one row up and one row. We can go from the top. Can we go from the top? So CS, it's been a while since I've done CS stuff. So we need to now go through all of the rows. Yeah. So if we go through the rows, let's see. d3.range. Yeah, so d3.range from, actually no, let's go with, so this creates a population, then we need to call it with, let's go with const. Okay, I'm gonna just try this for now, just so I can get my bearings. So we get the row, then we're going to pass in a population with the same CX, the same CY, width is going to be width minus 30, and height is going to be the same. So, and CY should be CY plus 15. Let's see what happens. I have a syntax error. Okay, no. Oh, maximum call stack size, obviously. Right, so here's what we do. We need to, we're gonna call this a create row. So this is going to be create row, and then we're going to have function create population, which is going to get CX, CY, and a width and a height. And it's going to calculate how many, yeah, there's no ending condition. You're right, Mitya. So we start with const nx equals math.floor width divided by 50. No, we don't need that. Const n rows equals math floor of height divided by 15. And then we go with d3.range 0 to n rows, and we map that like this. So we map it, and for each of those we're going to call a create row with CX, CY, and then the width, let's keep it the same, and we're not actually going to need the height, but actually CY is going to be Y scale of I. Perfect. And now we're going to create the Y scale, which is going to be another point scale. So we say const Y scale equals D3 scale point dot domain D3 range 0 to n rows, like that, and the range goes from CY minus height divided by 2 and CY plus height divided by 2, and that needs to be in an array. Cool. Now what we need to do here is just return the row. We return the row, and we get here const rows equals d3 range, and then we can return rows.reduce. We're going to get the population and row, and we return /population row, and this should give us a flattened array. Perfect. So we now have a flat array of a population, and to make it prettier, we're now going to reduce the width every time that we go through an iteration of this, so that we can make it so that it looks better. Basically, it's not going to actually impact how this behaves, but it's going to improve how it looks. The top bit is cut off because I'm running out of SVG over there. So the center of each circle is positioned exactly at the 0 height, or the 0. Yeah. So if I move this down a little bit, you'll see they stop being cut off. Okay. So we have a population, generates a population oriented around CX, fits into width and height. We don't need that because we're not passing in the height. Now let's make the width a little smaller every time. How do we do that? We can, but here it's going to be interesting, because if we are, I'm going to use a scale for this as well because I'm lazy. So we're going to have a width scale of I, and then we're going to define the scale. Const width scale is going to be d3 scale ordinal, I think. Is it ordinal? No, not ordinal. Point scale could work, but no, it won't. What we want is a threshold scale. Is it a threshold scale or similar to quanti-scale? They allow you to map arbitrary subsets of the domain to discrete values in the range. No, I think what we want is a linear scale. Let's try a linear scale. Scale linear, which is going to have a domain that goes from 0 to width divided by 2 to width, and height divided by to n rows divided by 2. So 0 to n rows divided by 2 to n rows, and then the range is going to be, we start with a width of 15, then we have a width of width, and then we go back to 15. Let's see how well that works. Fuck. Yay. That kind of worked. That worked really weirdly. I wonder why it did it that way. But this is good enough, right? Do you guys think this looks good? Or should we... Let's increase the height a little bit. So it's 300 and at 200. Okay. So we have a population. It's a little weird because this would look better if it was a circle, but let's go with this for now. Ship it, yeah. Okay. Figure out how to make this create a circle. So I think obviously what we would have to do is, this is the part that would have to do trigonometry. So how to make, we would make this a circle with trigonometry, but let's keep it like this for now. It's okay. So we have git status, git commit -a -m, let's say, placing a population on the page. Cool. So we have a population that's going on the page. Now the next step is turning this into a widget that shows Should we have a widget for this? Or like component maybe? Yeah, if I make the SVG bigger, I would get the full diamond shape, I think. But this is okay for now. Wow. 16 people on the stream. We were up to 25, but I guess the boring parts were boring. So I'm gonna actually put this in a, let's turn this into a hook. And we're going to make a population with, and the reason I'm going to make a population, so I think candy cane, the last ball at the bottom here is a, if I do this, I think that will make it appear. Maybe not. I think it's an off by one problem somewhere. So what I want to do next is figure out how to make the, we're going to make this into a widget or into a component so that it's going to be easier for me to include in a blog post that I'm going to create. So let's say population with cx equals 400, cy equals 200, width equals 400, and height equals 300, like that. And then we create a new file, import react from react, export const population, come on, population equals cx, cy, width, and height, and it returns stuff. So source population.gs, like that. We're gonna need d3, and we're gonna need the person as well. Let's actually just move all of this stuff. I'm happy to hear that, Yardcraft. Oh yeah, the React D3 Christmas series, that was fun. That was also a while ago, I think. So get all of this stuff. I don't need D3 anymore. And we're going to call this actually function use population. Should it be use create population? Use create population. Use init population. No, use population, which is going to take the cx, cy, width, and height, and it's going to return stuff for us. So use population is going to be a thing like that. So use population, we make it into a React hook. We say const population equals create population. Const population creates population, return population. Then we go down here into the thing and we say const population equals use population with a cx, cy, width, and height. And then we return, return population.map with p goes to person, person x equals p.x, y equals p.y. Now, this isn't a whole lot better, but it's going to help us going forward. I think we need to import population. Import population from ./population. Does not contain a default export. Like that. Yay. Mitya asks if I like creating SVG elements with React better than the usual append. Yes. I do actually enjoy doing it with React a lot more because I think React is better at rendering and managing that sort of thing, whereas D3 is better with the calculations. And Puyan Motiwala, I don't know how to pronounce that, sorry, asks if I can create a video to understand each different D3 components. That would be an interesting project, and it would, I think, take a while, but I'll think about it. Is there any D3 component in particular you're curious about using it with React? Because they all follow very similar patterns, I think. Okay, so we're rendering a population here. Now we need to make sure we're not creating a new population every time. So maybe I can, let's move this out of that the hook and say const, yeah, we're gonna need to have state changes for this. So we're going to have population and set population, which is going to start with use state that starts as the create population part, like that. And we need to import use state from React. Use state from React. Perfect. So that still works, except now we're no longer recalculating the entire population every time that React touches this stuff. So the next part is making somebody infected. So what we're gonna do is return a fragment, and that fragment is going to have a button that starts infecting people. Should that button be here, or should, no, that button should be in an external component, huh? Yes, that button should be in an external component. So we're going to change this SVG to have a width of 100% and a height of 500. And underneath is going to be a button that says infect. Bam. Infect random person. Yes, exactly. So Candy Cane recommends using parameters for different things, and we are going to actually do that. Cool. Okay. So now we need to infect a random person. How do we infect a random person? On click, we need to this is where this stuff is gonna get annoying. So maybe the population part should actually God damn it. I think I walked myself into a corner. So what we're gonna do is, instead of having a button to infect a person, we're going to have an on-click listener on the person directly, and when you click that, we're going to start the animation. Yes. So person, or should we should probably start with, so I'm having a hard time deciding how we should start the actual simulation. Should it be just automatically started? Because we are going to want to add, we're going to want to add the ability to change who's being maybe the population should just be rendering and shouldn't be generating its own thing with the hook, and that should be controlled from the outside. Will that make our life easier? Yes, it will. All right, so that's what we're gonna do. We're gonna have the population component as just a renderer. Should we? Or should it be the entire simulation? Actually, let's do it this way for now. When you click on this, you start the animation and a random person gets infected. So this is going to be a grouping element that's on a thing, and should it just render its own SVG? No. So yes, it should. So we render its own SVG. Sorry guys, I am kind of making this up as I go. So SVG with a style that says width and height. So width and height, like that. that should work. And we don't need this SVG anymore. Okay, nice. So now what? Why is this being silly? Oh, right. Because now this needs to be centered on width divided by 2 and height divided by 2. Okay. And let's give it a width of width minus 15 and height minus 15. So that there's some padding. Okay. So we've got a population now. And now we're going to add buttons and stuff to control what's going on. So now we can here add a button that says infect a person. No? Come on, why is the button not showing up? That makes no sense. Oh, because it's still in the SVG. Duh. So we rendered that stuff. And each population is going to have its own controls. Infect a person. Bam. And let's put this in a div so that it's all nicely at the bottom. So when you click this, we're going to take a random person from the population and infect them. On click equals start simulation. And then start simulation is going to come out of use population. So population is going to return the population and the start simulation like this. So we return the population, we return the start simulation function, and the start simulation function is going to be here. So we say function start simulation, which for now is going to console log something so that we can make sure it's working. So when you click this, we should get a console log. Yay, hello, it says hello. Perfect. Now the next thing we need is to actually infect somebody. So we're going to take a start simulation is going to say set population with how do we infect somebody? This is gonna be interesting. So we're gonna start by infecting a random person, which should go by, so we say set population, where we take population, and how do we get a random person out of the population? We have d3.sample, right? I think we have d3 sample. Samples, no. Shuffle. d3 shuffle. d3 cross ticks, increment tick step, randomize the order of an array, compute the contingent merge multiple arrays, create an array, reorder, generate tick step, range, transpose, zip. I wish there was a way to get a random person. So we're just gonna use the old school approach of changing one of them. So we say set population, where we can just take the population. So we're going to say const pop equals population. Avoid changing values directly. So next population is population, and then we get next population of math.random. Oh, actually, I know we have d3 gives us random functions. d3 random can give us random uniform from min-max. Perfect. So we can say d3.random uniform from 0 to next population dot length -1. So we call that, we get a random sample, and we say dot infected equals true. So we're now basically infecting a random person. Infect a random person. And now here in, and when, so now we need to make sure that we're passing in whether a person is infected or not. So what we can do is just splat the entire person into there, and we should be able to click this and get somebody who is infected, except it doesn't work. Awesome. Why doesn't it work? What does d3 random uniform return? Let's try using a debugger. Press infected person, and we say d3 random uniform from 0 to next population. 0 to next population dot length -1. This should give us a function. d3 is not defined. Why is d3 not defined? Of course d3 is defined. What can we do here? Wow. Okay, there's a lot more boilerplate here than I was hoping there would be, but I still think we're making good progress. Okay, how do I get a random element from an array? Random element from array JavaScript. Come on, this shouldn't be so hard. Math floor, math random, item select. Okay, that will work. So math floor of math.random times next population.length. So we set that to infected equals true. So let's see, const person equal const random person. We say person.infected is true, like that. No, okay, prettier is being silly. So now will this work? We should now get a random infected person. No? Ha. Okay. So what's the next thing we need to change something? Something's not working. So what if we console log the person and we also console log the population? So, oh, that's what's wrong. So here I need to actually use the next population when I'm updating state. Infect, awesome. So we now have a way to infect random people. So that works. Cool. Now we need to make sure that this starts spreading. Now how do we make this start spreading? So now we're gonna have to start the actual simulation and make the infection spread through the population. So get status, get at source, get commit -a-m button to infect random person. Okay, so now the random infections work. The next step is making sure that the simulation starts running, and on every tick of the simulation we're going to basically update how the stuff is spreading and where it is. That's the theory, at least. So what do we do? Now here we are only going to show this button if there is currently nobody infected in the population. Yeah. So we say population.find where p.infected. So if that exists, then we render null, otherwise we don't. Let's see if that works. We infect a person and the button vanishes. Cool, that's good. Now the next thing we need to do is make sure that each of these persons has a unique identifier, so that they actually, so that when we start animating and moving things around, they don't React basically doesn't get confused. So when we're creating the population, we are here, create row, create population. How are you going to spread the virus? Yes, that's going to be the interesting part, Westlife. So the idea of spreading the virus is that I'm going to make all of these objects, I'm going to make all of the objects move a little bit, because people in a population usually move. So I'm going to make them move. And then when they're moving, I'm going to run an algorithm to see if they've touched anybody on that tick of the animation, and then use a virality factor to see whether that person gets infected or not. That's the theory. So we're gonna, and the way I'm going to detect collisions is using the B3, the Quadtree approach, this one, because this is really good for collision detection. So let's see why. Let's generate a key. What should the key be? We can make it, should we just generate UUIDs for everyone? Let's make UUIDs, because why not? Yarn add UUID. Oh, no, we can use look ed something published a library recently for developing, for creating this guy. Look Edwards UUID, is it similar? Look ed05 UUID. I know he made a library that's faster and super. Okay, hexoid. There we go. Yarn add hexoid. And let's use this to make IDs for every element in our population. It's a total overkill, but it should be fun and useful. So hexoid, extremely fast, perfect. That's exactly what we need. We say, so import hexoid from hexoid. And then this hexoid is going to just run okay, so hexoid of, let's say, 25 runs like that, and now everything should have an ID and React will stop complaining. Cool. React is not complaining, everything has an identifier, and we can see those identifiers somewhere, can't we? Are the keys not showing up? Oh well. Keys aren't showing up, but I'm pretty sure they're there because React isn't complaining that keys are missing. So we've got that. The next step is making each of these move. So now we're going to start an animation loop in the pop. So here we're going to start the animation loop, and then with the animation we're going to move people in random directions a little bit. Hey today, Poliner, I'm doing pretty well. How are you? So start simulation, and it infects a random person, set population, next population, and then we're going to start there's going to be a D3 interval. Yeah, D3 interval that's going to run D3 interval, schedule a timer that is called with a configurable period. Wonderful. So timer, where is it? Timer except the callback is invoked only every delay milliseconds if delay is not specified. No, what about timer? Schedules a new timer invoking the specified callback repeatedly until the timer is stopped. An optional numeric delay in milliseconds may be specified to invoke the given callback after delay. Perfect. So we're going to start. This should all be in a use effect, so we don't. I know what we're gonna do. We're going to set started to true. Set simulating to true, simulating, and we're going to have a state const simulating and set simulating equals use state, which starts as false, controls when the simulation is running. Simulation is running, and the reason we're doing it this way is so that we can clean up after ourselves. So simulating, we set that to true, then we have a use effect here, and this effect is going to be what reacts to our animation. So runs the simulation loop. Now this needs to say d3.timer, which is going to run a animate. This is going to be the actual thing that runs, and that's gonna have to return false. So if simulating return simulating, so this is always going to return schedule invoking the specif until the timer is stopped. The callback is passed. If timer is called within the callback, so I need to make sure the delay. Okay, so it just needs to say stop or not stop. Okay, cool. So we have the timer simulating. Const t equals d3.timer, that runs the stuff, and it returns t.stop. So this is going to clean up afterwards. Stop timer when cleaning up. And yeah, King Dara, that's really funny. I'll get Corona just by making this simulation, you're right. Let's try just console log t for now, just to make sure that this is running. And now we should get a lot of console logs, and this is running. That should not be running. We should say if simulating is true, then we do this shit. So infect person, and we start running t, and when we restart this, perfect. We should also okay, I'm gonna have trouble later. So in the function, we also need to check if simulating is now stopped. We say t.stop. Enable stopping when state changes. I don't no, actually we don't need that. It's going to stop it either way. Oh, nice. I'm happy to hear that today. So today said that he shared my article about using REST and GraphQL together, and that they're now considering GraphQL. Awesome. Okay, where was I? So we need to here calculate the next state of our population on each tick. Now, how do we do that? We should also probably clean up this function. So we're going to say this is going to be iterate population. Yeah, iterate population. We're going to make a function here. Function iterate population, and this is going to do a bunch of stuff. So it's calculating the next state. First, we're going to simulate movement. So we say const let next population equals a copy of the population. So avoid changing stuff directly. So we make a copy, and then in the end we run set population with next population, right? So this is going to create the animation stuff. Now we just need to change state. So we're going to say first next population equals movement of the next population. So the movement is going to yeah. So we are going to, let's start with movement. Should people move? Yeah, let's do that. People move. And we're going to make a function called people move. Function people move which is going to get a population, and then it's going to say, basically it's going to go over it and make everyone move a little bit in a random direction. People tend to move around. This step makes that happen. So the people move population, we go with, we return population.map, and we get for each person, we get the person, and then what do? We can return the full person, and we say x is going to be x plus some small amount, x plus so now we need to make them move both to the left, to the right. They need to move anywhere, because let's start with this, x plus 1, and we say y equals y plus 1, and now you'll see the whole thing is going to start moving in one direction. So this is going to just be a proof of concept that the population moving actually works. Why did they stop? That's interesting. Okay, so everyone stopped moving. Interesting. Okay, so that's not actually working, which means we have to fix that first. Why is our population not moving? And I think I know why. Iterate population is not a missing thing here, but iterate population needs to I think I know. When we set state, we need to use the function notation. So we're going to say population is going to do this. Then we move this stuff in here and return next population. And I think that's going to make it work. Infect person, yes. Okay. So now everyone's moving and the whole thing is going in one direction. Now we need to make sure that they're all moving in random directions. So how do we make them move randomly? We need a random number between minus, let's see. So we say const random equals d3.random uniform that goes from -1 to 1, and then we just call plus random, and they should now all move in random directions. See, now the whole population is kind of wiggling around, and the next step is seeing how this wiggling is spreading disease. So people start moving around. That actually looks better than I thought it would. Get status, get commit -a -m. Population moves around. Now the next step is detecting collisions between these people and seeing whether they are so when they basically seeing what happens when people interact. So when they touch, there's a certain probability of them infecting one another. So which means we need to detect the collisions and then decide whether we are making the other person infected or not. All right. Nice. I actually was not expecting that to look so good. So we have people move. Now we need to get people collisions. How do we get collisions? So one way to calculate collisions is to compare everything with everything, but that will be a way too slow of a thing to run on every iteration of our timer. So what we're gonna do instead is generate a Quadtree, and then for each Quadtree we're going to look at how have I done this before? I think I have done this before. Let's see if I've written it down. Swizets collision detection Quadtree. I know I've done this before. Quadtree makes collision detection easier. Okay, n-body collision simulation with React, D3 and Mobex. Or there we go. Yep, I knew I wrote about this before. So this is the n-body collision simulation. This was back when I was still doing more videos. Okay, so we have that. Now let's see, where is the Quadtree implementation? There we go. Where collisions collision. Did I actually use Quadtrees? The subdivide space based on blah. Okay, perfect. So I'm gonna try to use this. Good thing I write blogs, right? And let's see. So we have the people move. Let's get let's just call collisions people collisions from next population, and we go here, people move function people collisions from the population. When people collide, they transfer viruses. Okay, so we have that. Now we get const width height of marble r, move marble, that's when it moves. Then we need to subdivide space with a Quadtree. Perfect. So for each one, so for each of the, but we only care about the infected people collisions, so we can make that easier. We only care about infected people. So we say const infected equals equals. Do I need sunglasses? Why do you say that? Population dot filter p where p dot infected. So if you're infected, then we care about whether you are yes, then we care who you collided with. So we have const infected, and we say infected dot for each dot map. Let's go for each. Dot for each, we get the person, and for that person, we get the Quadtree. Yeah. VS Code white theme. Yes, I do like the white theme. Okay, so person, we go D3 Quadtree dot extend goes from -1. So I'm kind of just copying what I did before. I don't actually remember why anymore. And I say this simulation step. Why did I use this? That is so dumb of me. Oh, I know how this works. So we're looking basically for yes. I am 50. How wide am I? My radius is 5. Oh, so if my radius is 5, that means I'm 10 pixels wide. Changing my battery so that my face starts moving again. Let's see if that worked. Is my face gonna be moving? Yeah, moving. Perfect. So basically, let's put a radius here. Const radius equals 5. R equals radius. Like that. Create row, create population, people move, people collisions. basically find people in vicinity of infected people. D3 Quadtree extend from radius times 2 and radius times 2 because we are a circle. So this subdivides space, subdivides whole space to find nearest candidates. Okay. D3 dot Quadtree extend, then we say x is d dot x, y is going to be d dot y because we have that as the same thing, and then we add all and we take all of them, so we take the whole population filtered by where p dot key is not person dot key. Okay, so this should now give us the space const subdivided space equals Quadtree stuff, subdivided space, and then our candidate const candidate equals subdivided space, where we try to find something at person.x, person.y with radius times 2. So this is going to give us candidates, I think. I'm not sure if this is going to work with, I guess this is basically predicting that we can only collide with one other person at a time, right? And also we don't care if you're colliding with somebody who's already infected. So let's also filter out anyone who is infected. So everyone not infected and not current lookup. Okay, so this is our nearest candidate. Person nearest to current lookup. Yeah, person nearest to current lookup is the candidate for a collision. Candidate for collision. And now we gotta check whether that candidate is yes. So basically this is returning another person that is within the same space as the width of our circle, and we can then check if they're actually touching. Then we can decide whether that is a collision. So let's say map, and we're going to say const collisions equals all of that stuff, and then we return the candidate if the candidate exists, else we return nil. So if there's no candidate, we return nil, and then if the candidate exists, we say so that's already a bounce. Oh, actually, that's good. So we return the candidate. Person within radius times 2 of lookup position. Yes, so that's how that works. So we should now get a bunch of collisions, and we return collisions filter where the person isn't null, where P is not null. Okay, so this should now give us a list of potentially, where were we? Person.infected people collisions. let's console log the people collisions on every iteration and see if that's actually working. And this is where this might become super slow. So we're getting a lot of undefineds, but we're also getting some actual collisions. So that's good. Now we need to make sure here so we are returning candidate. If candidate exists, we return the candidate, otherwise we return null, so that we can actually do the filtering. Return candidate if candidate null. So now we're not gonna get a bunch of defaults, but we are getting people who are colliding, so that's good. Now we need to make sure now we need to decide if any of those people are getting infected. So let's see. Person console log people collisions. So we say people collisions. Now how do we make some of these actually infected? We need to go through them, and let's say let's run an infect function. So we're going to say next population is infect of next population and the people collisions. Okay, so we're going to say infect people. Now infect people is going to be another function up here. So function infect people takes a population and list of collisions, returns returns population with more infections, basically. Decides who got infected. So we infect people, we say population and collisions, or came in contact. Yes, contacts. Let's call it contacts. List of contacts with infected folks. Now we have that. So what does contacts look like? Let's return the population right now and console log the contacts. Let's see. Contacts, is that an array of arrays? So it could be an array of arrays actually. No, it's fine. So we have the contacts. Now we need to remove those people from the population so that we can then add them back whether they're infected or not. So we say let population equals next population equals population.filter where p.key so keys.include p.key. We say const keys equals contacts map p.key. So we're basically now we're filtering out anyone who touched somebody who was infected. Then we're going to decide whether they're infected, and then we're going to put everyone back into the population. So return next population and contacts. Now we say, what do we say here? So for each one of the contacts, we decide whether they get. For now, let's infect everyone. So contacts equals contacts.map with person, and we say p.infected. So we're returning the whole person, and we're saying that infected becomes true, like that. So now let's see how well our virus spreads if everyone who comes in contact with an infected person gets actually infected as well. So, well, okay. Keys.include is not a function. 1 2 3 4 dot oh, it's includes, not include. Keys dot includes p dot key. So we infect a person, and what? That was fun. Not includes. Okay, let's try that. So we infect a person, and now you see the infection is spreading really fast. That's awesome. 2 children with the same key. Keys should be unique. That's a problem. So we have the problem that our filtering is not exactly correct. But we can see that the infection is spreading. So that's cool. Now we have a spreading infection. Awesome. Now why is this not working? You see, and they stopped moving because of that. Okay. So now what can we do? What can we do here? What I was trying to achieve is making sure that we don't get basically trying to make sure we don't get duplicate keys, but we are still getting duplicate keys. So if anyone has any ideas why that's the case, I would be really happy. YouTube is pausing the video every now and then. I wonder why. It could be no, I think, yeah, I'm not sure why that would be happening. Maybe my computer is not actually keeping up with the stream very well. So let's see, contacts map. Oh, let's see. Okay, so we can also do this with a sort of different thing. Yeah, okay, let's do it this way. We're going to, instead of doing the whole filtering things out of the population and then putting them back, we're just going to map through the whole population and decide for each one whether it's becoming infected or not. So here, next population, and we say if p.key is, so if keys.includes candidate key, contact keys, so contact keys.includes p.key, otherwise we just return it unchanged, return population.map and const contact keys equals contacts map p.key. Save. Now if that include, what's it complaining? Oh, it's not always returning. So if this is somebody, this person came into contact with an infected fellow, so we return the whole thing and also say that infected is true. Okay, now let's see. Next, we're going to make the infection have a different virality factor. So if we infect a person, now they're all gonna get infected very quickly. See how fast it's spreading? And the more people that are infected, the faster the whole thing spreads. So that's good. We now have a spreading infection within a population. You see how fast it goes when people are close together, and then as soon as it touches a new population, it goes really fast. Cool. We should also probably have a count of how many people are infected. Yeah. Okay, so git status, git commit -m, spread the infection. Okay, so the infection is now spreading. Now the next step is making sure that people can die. Or, well, some people die, some people get better. And how do we model that? 100% infection rate. Okay. Now the next step is making people die. So we have people collisions, then we say next population equals. What should it equal? Oh, next population, we should say people die or get better with the next population. So now when people die or get better, this is going to be a function again. After n iterations, you either die or improve. So function people die or get better from the population is now going to do what? What happens? So we again map through the population, return population.map, and for each person we are going to say if how do we keep track of how long it's been since you got infected? Instead of infected being true, it should be a number, and the number will be which iteration of the thing we're on. So here where the timer is running and iterating the population, let's see what is it giving us. It's giving us time elapsed. So iterate population gets the elapsed time, right? So when we are elapsed, we can infect people with the next population, the people collisions, and the elapsed time, and then the people die or get better will get also the elapsed time. Elapsed time, elapsed time, elapsed time. Population gets the currently elapsed time, and this gets contexts and the elapsed time who got infected. Being infected gives you, we keep track of when you got infected with elapsed time. So infected becomes elapsed time, and here we're going to say when you are the first person who got infected via the button was infected at 0. So population P, now let's see, population map P, and we say if P dot infected, then we do stuff, otherwise we just return P, and if you are infected, then we say return R. Return, where are we? I got lost in my code. People move, people collisions, infect people, and then people die or get better. So how long does it actually take to die from corona or to get better? So this is where it's going to be interesting. We need to have a death rate, and we need to know. So let's say it takes 3 weeks to get better. We can say that each iteration here is some amount of time. So we're gonna set this to, let's start with some magic numbers. If P dot infected, average death is at around 17 days. Perfect. That is a great data point. So if elapsed time minus P dot infected is more than time to die. Yeah, time to die. Let's call it iterations to die. then iterations to die, p dot infected divided by 60. So if you die, then we return the entire p and we say dead is true. Otherwise, so this is now 100% mortality. 100% mortality. Iterations to die. Yeah, that's fine. Otherwise, we again just return the p. Now this is 100% mortality. Let's say iterations to die. Const iterations to die equals, let's say, 20. Now let's see what happens. So we infect a person, and we should now now infected is not working because it is, oh god damn it, if infected is not null, is not undefined. Now let's make it not null, and we start everyone with infected of null. Now let's see, infect a person. Okay, so now the infections are not spreading anymore because we're doing something wrong. Is elapsed time not being passed in? So people die or get better. Start simulation, iterate population. Let's try console log elapsed time. Let's see if we are in fact getting the time. We are getting the time. That's good. Okay, so when we infect infect people, do they get does the elapsed time happen here? So elapsed time is that passed in. Infect a person, that is passed in, perfect. So now let's see, is it getting set? Console log elapsed time. I think we're still getting here. So infect a person. Come on, contact. No? God damn it. Come on. Get in touch with someone. Something went really weirdly wrong. So what if we set it to true? Will that make it work again? Okay, no, so something else broke. Somehow when we were changing this stuff, we broke it so that collisions aren't working anymore. That's kind of weird. So we get set population person dot infected is 0. People move, next population. So people move. What do people collisions look for? Aha. Here we need to say when this is not null. And now it's gonna work. So infect person, yep. And we should eventually start seeing them die as well, I think. Now if we see them die, let's see. So next population, people die or get better. We should make sure that elapsed time, this console log, let's see if iterations are iterations counting. No, let's console log it down here. So console log iterations since infected are elapsed time minus p infected divided by 60 because we have roughly 60 frames per second. So iterations since infected, yes. Now what is the iterations to die is 20. Now why are people not dying? I got lost in the code again. Help. People die or get better. So actually let's call it length of infection. length of, yeah, let's call it iterations to die. Iterations to die. And we can also, now we don't need to math round. Now, but when they die, we need to make sure that that is a higher priority than being infected, because we are not unsetting their infectiousness. We're just saying that they're now dead. So we should now actually see people start dying. There we go. So people are dying. Yeah, maybe they're protected by toilet paper. You're right. So people are dying, but when you die, let's say that you, at the very least, you stop moving. So here, when you're moving, we need to make sure that if you're dead, you don't move. So we say p.dead, we return just p, otherwise we return you moving. So now the people who die are gonna stop moving. Let's see if that works. Yep, they're now all there. The problem is that they're still infectious. Although in a real population, so here we have a virus that is actually too deadly to spread effectively. So because everyone dies who comes into contact, and they die too quickly, the virus isn't able to get the entire population. So that's an interesting result right there. Experimental result about how epidemics work. This is also, if you've ever played something like Plague Inc., you'll know this. What was I gonna say? Yeah, you'll know that you can't make a virus that is too deadly, because then it doesn't spread. So we have that. Cool. Now we can make them also get better. So this is now 100% infection rate and 100% mortality. So instead of 100% mortality, let's give it a mortality factor. So const iterations to die, const mortality is going to be, I think the average mortality rate for corona is 3%. So let's go with let's say 4%. This is a very high mortality rate. And we're going to say that after 20 iterations, you either die or get better. So here, where are we? People die or get better. Here, we're going to say iterations to die. Then we say if math.random. So now how do we get 4%? How do you get 4%? So basically, if math.random is, oh yeah, we can just go like this. If math.random is less than mortality, then you are dead, otherwise you are recovered. So we say mortality dead is true, and otherwise dead is still not false. So otherwise you become infected null, and we say that you are recovered true, right? And then when you become infected here, we're going to say that you are not recovered, just in case. So now we should see people just count the balls and take 4% of it. Yes, that is also one way of doing it, but I wanted to make so this is a different approach where you take a random number and you say if that number is bigger than a certain thing, you are now dead. But we should probably take a uniform number. Let's see, how does random uniform give us? Or D3 random uniform form a uniform distribution, returns a number greater than or equal to 1 and less than 5. Oh, actually, that will make it easier. So if we say d3.random uniform of 0 to 100, And if that is less than mortality, then you die. Not dead should not equal recovered. So the way I wanted to make it is that okay, so Gagi, how long do you think it should take for people to recover? Should those be different than so like, do you think you die faster than you recover from the virus? Let's see what happens now. Oh, we got a very unfortunate random person. Again, an unfortunate. There we go. So now it's spreading, and people are recovering and then unrecovering, which is cool. But nobody is dying yet because the 4% death rate is pretty low, shorter than average time to recover. Okay. So iterations to die, we go with that. Now Gage is right. We should make it so that otherwise return P, and then if elapsed time is more than iterations to die, else if elapsed time minus P dot infected, if that divided by 60 is more than iterations to recover, then you recover, right? So we return P dot blah, and iterations to recover equals iterations to die times 2. Okay, so now let's see what happens. Now we should get people. So now we have a virus that is spreading and doing things. Cool. And we have people who are dying and recovering, and eventually we should see the entire population with a it's kind of weird that not that many people are dying. That's kind of wrong, I think. Okay. So infected, recovered, dead. Now, why aren't more people dying? Let's turn up the mortality to, so let's see, mortality. So random uniform between 1 and 100. What if we change this to 50% mortality rate, just to see that people are gonna die, that more people are gonna die now? Because I'm trying to see whether this even works. Because if it's not working, then now is the time to find out. Why is mortality not happening? Yeah, why aren't more people dying? I think there's something wrong with D3 random uniform. Uniform. Aha, I knew it was. There we go. Now there's gonna be more people dying. So West Live, so what I'm trying to do is parameterize the mortality rate. So there we go. Now it works. Because so that's the thing. Mortality is checked every day, depending on how long you've been sick, which I think is a better way than going with a global number of infected people and giving it a mortality based on that number. Because we're kind of talking probabilities here. You have a probability of dying in a certain amount of time rather than dying immediately as you like, it's not a global statistic, it's a personal statistic that gives you a probability for you. So basically, when you die, you have on average, when you get infected with corona, you have on average a 4% chance of dying within the next 3 weeks. So in 3 weeks, you'll know whether you've recovered from the disease or you died, basically. So we now have a virus that is still way too strong, but that's a good, it gives us a really good approach. So what we can do now, now we can start making this more interactive and making it so that you can configure how these things work. Git commit -a-m, people die or recover. No, it's not 4% of a random population, it's 4% of the infected population. It's not having corona in your community doesn't mean that 4% of the people in the community are going to die. 4% of people who are infected die, which is a very different statistic. Cool. So we have that part. Now what's the next thing we need? Now we need to make all of this a little bit more configurable. So I want to add, can I link my GitHub? It's not on GitHub yet. Okay. I think Gage is right. Your chance of dying every day should be 4% divided by 30. Yeah, that makes sense. Okay. So let's see. Iterations to die. Now let's just take iterations to recover. And let's see, if you're infected, so down here, infected people have a mortality percent chance of dying every day until they recover. Yeah. So we say if you're infected, and then if d3 random uniform const random percent. Okay, let's do it this way. So if d3 random uniform from 0 to 100 is less than mortality divided by iterations to recover. Where am I? But I think that's not gonna work correctly, because we're gonna get mortality divided iterations to recover is less than 100. So this needs to be 0 to 1. Have a mortality percent chance of dying every day until they recover. So if we say, does random, let's go to, how do I test this? I know. Let's run node, and we're going to say import asterisk as d3 from d3. Const d3 equals requires d3, and we say d3.random uniform between 0 and 1 returns what? Okay, so that works. That's returning. Okay. Yay, so we are now firmly in the mathematics department, which is not really my strong suit, but I'm gonna go with mortality evenly distributed across your entire iterations to recover. And King Daro is right that that's not actually how probabilities work, but for this simple simulation, I think that's going to be good enough. So if you get a number that's lower than, so 4 divided by 40 gives us 0.1. Perfect. Yeah, so King Daro, you're right. That is, we should probably use a proper mathematical model for this, but this is already getting pretty complicated, I think. So if that happens, then we return p and we return that equals true. And if you are, else if that's more than iterations to recover, then we say that you are recovered. Let's see if that works. So if D3 random uniform is less than mortality divided by iterations to recover, then we say that you die. Otherwise, if it's been more than iterations to recover, then you're fine. Otherwise, we return a normal person. That's where I did wrong. So we return that. This has a body like that. Then we have this else. Wow, I'm getting so confused with this code. Okay. And then else we return P. There, now it should work. So, okay. We run the infect a person and everything just crashed. Nice. Each child should have a unique key prop. So what did we do to make everything crash now? If P is infected, we return stuff. Otherwise, so if it's not been, then we also need to return the person. Now it's gonna work. Infect the person, and they're getting infected, and they all died. So I think our mortality rate is too strong right now, guys. Let's change this back to 0.04. See if that makes it better. Okay, so now people aren't really dying, they're recovering a lot. Okay, some people are dying, that's good. It sounds really weird when I say that, doesn't it? I'm like, oh, some people are dying, that's good. Cool, so I'm gonna call this simulation working now, because I think we've exhausted the limits of our ability to parameterize probabilistic calculations. So I'm gonna say git status, git commit -a-n. We say some people die, some improve. Okay, so some recover. Now the next part, we don't need cx-cy anymore, do we? Cool. So use population. All right. Cool. So we've got that part. Now the next thing we need is to make all of these things. So King Daro, we don't know yet actually. There's currently little evidence whether you become immune to corona or not after you've been infected or after you recover. There have been some cases of people getting it again after recovering, but we don't know yet how that works. So for now, I'm allowing reinfections, but we can easily make that, what was I going to say? We can make that configurable, which is where the interactive part comes. So let's make this interactive now. Yeah, some people recovered and still died later, which is also true. Okay, so let's have now a paragraph. So we're going to show population is going to be population.length, population 243, and let's see. We should also then say infected is population filter p dot infected is not null dot length. So we have how many were infected and then how many died. Dead is population dot filter p dot dead dot length, and recovered is population dot filter p dot recovered dot length. So we have, in fact, okay, so we now see how this is spreading. We have people who died, people who have recovered. That's great. It's gonna jump around a little bit, which is something I'm totally fine with. Yeah. Okay. So population 243, infected 45. Should we also show iterations? Let's not show iterations because that's going to be hard to show. Now, what we need to make configurable is the mortality rate and stuff. How do we make that configurable? What's a good way to make that stuff configurable? We should make it into a like sliders. I think sliders would work. So another P, and let's say input type is, how do we get an HTML5 slider? HTML5 slider input type range. Awesome. So input type, yeah, a fancy Conway's Game of Life, you're right. Input type range. So let's make a range for, what do we need? We need to have mortality rate. Oh, we also need to have infection rate, or like, yeah, virality. Yeah, virality makes sense. So input type range, let's have a, how does input type range work? Input type range, can I define the small, like the low and the blah, min max, that's what I was looking for. So if we say min equals 0, max equals 1, value equals 0.04, then why doesn't it let me volume max value 90 step? Actually, let's do it this way. Min is 0, max is 100, value starts at 4, and we say step equals 1. If you limit movement, you can simulate quarantine measures. That is exactly what I was thinking about. So why doesn't the slider slide to a form field without an on change? Oh yes, so that's why it's read-only. So we have that. Now let's call this mortality. Mortality rate. No, mortality, and we say, how do we make these inputs so that they're easier and nicer to read? And instead of infect a person, we're gonna say start simulation. So input type range min is 100, value is going to be mortality, and then on change equals to event where we say set mortality to. So Carlos Chiesaro, I'm not sure if we should remove dots after they die, but I guess we can. It's kind of hard to say. Like, I'm pretty sure that a dead person would still be infectious for corona if you like went and touched them and stuff, but in reality we wouldn't really go touch them, I think. If target.value, so we set the mortality. Now we need to use state for that. So we say const mortality and set mortality equals use state that comes from the props let's just get props, and so props dot mortality, and we say width, so props dot width, props dot height. Ah, come on computer. Height, no, width. Why is this height? Okay, there we go. Height, and then we pass in mortality, and if we go now here, we're now getting mortality as a thing, as a prop. So mortality comes in to use population as an argument. We start the simulation and iterate population should people die or get better. This should get the mortality, the current mortality rate, shouldn't it? Now the question is, yes, that state should in fact be inside the use population hook. So let's do it that way. Up here we're going to have const mortality is that. So we start with the should we have a starting mortality rate? Yes, we definitely should. So let's, with height mortality, and let's call this so now I'm having the problem I'm having is that these variables are shadowing each other. So if we say width height, should we just say props up here? Yeah, let's say no. So we get width and height, and we get the default mortality. Default mortality. So default mortality, and we pass it in here as default mortality of 0.04%. We can now say here again back to width and height and default mortality, which is going to be no width and height. So width, height, come on computer, or come on Swizz. So default mortality is 0.04, and this is going to then return the mortality and the set mortality thing. So here we return mortality and set mortality. This is going to be very confusing, I think, but it should allow us to change this stuff. That's good. Oh, and it's not 0.04, it's actually 4. So we have 4% default mortality. Now here, when we go into people die or get better, this should now get the mortality rate. So mortality, and the mortality is going to be, let's say, mortality divided by 100, so that we have so that we go from percentages to the other percent to floats. So mortality divided by iterations to recover. So now if I start the simulation, I can go to 100% mortality, and that should in theory make it so people die faster, I think. That did not quite work. Or maybe it did. No. Okay. Interesting. So with this much mortality, the simulation doesn't have anywhere to go. Let's console log the mortality here so that we can see if this way of controlling the simulation is even working before we start adding more controls here. So start the simulation. Mortality is 0.04, and yes, it does not in fact does not change. Interesting. So mortality never updates here. Fascinating. So what we need to do is make sure that this use effect is also also needs to depend on mortality, because otherwise we keep running it with the same value. Now it's not console logging anymore. What? Did I delete that line? Yes, I did. Console log mortality. Okay, let's try again. So start simulation, and then whoa, and then I changed that and everything got confused. Wonderful. Okay, let's make it so that you can only set this stuff in the beginning, and then you pass it in and you can't change it anymore, which will make more sense. So let's go back to having mortality in the population. So mortality, and we don't return that stuff here, like that. And here we say const mortality starts with default mortality, and we're gonna say default mortality is 4 for now. So we have mortality set mortality, we update that stuff, and here we're going to say mortality %, just so that people can see. So change that and it goes up and down. Perfect. And then once you start the simulation, let's return whether we're currently running simulating, and we say if here. So if we're simulating, we don't render that button, and we also don't render any of the controls. So simulating null, otherwise we return all of this stuff. Okay, now this should give us better control over what the simulation is doing. So we can increase the mortality to 70% and start the simulation. And in theory, people should be dropping like flies, but they aren't. So I'm going to go back here and console log the mortality, just to make sure I'm passing it in correctly. So mortality starts at 4%. We increase it to 70%, start the simulation, and it is nan. Wonderful. So set mortality with number EV target value. Let's get that working. So 60%, start simulation, still nan. So what is it being set to? Why? That's confusing. Why am I unable to get the target value correctly? So console log. No, wait, actually that is working. So that means I am incorrectly passing it around somewhere. So number v target value, EV target value. Come on, let's make this shit interactive. So default mortality goes here. We use population. We need to actually pass in the mortality, and then it's going to work. So let's see, mortality 58%, start simulation, and yes, okay, so that's working. We now have a configurable simulation that we can start whenever. So the next step, status git commit -m configurable mortality. Okay, now let's make time to recover also part of the settings. So simulating, we have mortality, then we have let's see, let's make it probability of transmission, virality. So virality. Actually, you know what? let's make a simple component for this so that it's going to be easier for us to set. So we're going to say slider, which is going to have a label of mortality and a value of mortality and a setter of set mortality, right? So we create a slider component up here, const slider equals label. It gets a label, it gets a value and a setter, and it returns all of this stuff. So label, input range, value, setter, value. So that's going to make our life a little bit easier. Down here, then default mortality. So we have the virality, set virality, and default virality of, let's say, 50%. Does that make sense? Default virality, and that's good. These are going to be numbers that I'm gonna have to actually check, because I don't know, especially when I turn this into an article and I want to make sure that that people can compare like flu to coronavirus to other things. I want to make sure that we're doing it correctly, that in a useful way. Basically, what is the probability that you actually get something after you after you get infected with it, you know? Does that make sense? Like, if you come into contact with somebody who's infected, what is your probability of getting that thing? Virality, set virality. Okay, so that works. What is it complaining about? Each child must have a unique key. I don't care about that here. So we get, actually, let's just turn this into a fragment, and then React isn't going to complain. Now we need to actually use the virality. So we pass it into the use population, and use population here gets the virality, and where it infects people, it gets the next population, the people collisions, the elapsed time, and the virality. Now this virality is going to be used here. So infected virality. So if that includes the thing, then if d3 random uniform of 0 to 100 is less than the virality, then you get infected. Otherwise, we return p. So now when you get into contact with somebody who's infected with the virus we're simulating, you only have a 50% chance of getting the thing. And it's still going to spread pretty well. And Candy Cane asks if there are any shortages other than toilet paper. Yes, hand sanitizer is very much in shortage. There's also so hand sanitizers, toilet paper, paper towels, a lot of stuff like that. There's also stuff coming off the shelves of stores very quickly. So that's another one. What else? Yeah, this is like just random things. There's no real shortages, but things are just, you know, yeah, I kind of lost my train of thought there. But yeah, everything's fine in San Francisco pretty much. So we have the virality factor now. What else can we do? Then we can say, so iterations to recover. Let's make that. So what is the iteration length of infection? Length of infection. We say value is length of infection, and set length of infection as the setter. Okay, and we say const length of infection, set length of infection, and use state default length of infection. So we pass that in. We're gonna say this is 20 to start with, right? No, 40 iterations to recover. Where is it? Length of infection is 40, and we pass that in here. People die or get better. Then we have length of infection. So this is getting so long that I should probably consider an object. Length of infection, so people die or get better. We have population, elapsed time, mortality, length of infection. Let's turn the, that's fine. Well, length of infection, so bam. Instead of iterations to recover, we now have length of infection. And length of infection is not a percentage. God damn it. How do I make this better? So now see, this is why I made the slider component to make it easier to use, and now it's actually harder to use because I have to add an option, show percentage equals false. 40, no. Label, so, no, what is this? Unit. It's a unit. Unit equals ticks, steps, yes, steps. Steps. Now here we have unit equals percentage unit. Okay, so we have 40 steps. Now how long the infection lasts. Start simulation. Now we should get more people being infected. And the next one is quarantine measures and how much people are moving. Whoa. So interesting. Both people recovered because the infection was so long. Yeah, candy cane, I think they do have a bit of a size advantage, eh? That's weird. I wonder why with a longer length of infection, fewer people got infected. That is unintuitive, so that probably means something is wrong. Ah, that's what's wrong. There we go. Now it's gonna be perfect. So we make a very long infection, and now more people should end up infected. Now let's make movement limited or not. So rate of movement length of infection let's make it social distancing. Social distancing. And let's move this one all the way up because this is going to be the most interesting one to look at. So social distancing, the unit is empty. Social distancing. Oh, actually, let's have percentages for this. So social distancing and set social distancing. Set social distancing. So we have default social distancing equals 0, const social distancing and set social distancing equals use state default social distancing. Yay. Okay. Length of infection, social distancing 0%. Now when we say social distancing with 0%, what does that mean? We want to basically, this is when people are moving a lot. So social distancing, where are we? People collisions, people move. This is where social distancing is going to come into play. So we pass it in. Simulating people move. Where is it? People move. Next population and social distancing. We pass that into the use population method. Social distancing, and then here people move, we're gonna have social distancing. Now how do we simulate social distancing? Basically, when there's no social distancing, people are moving a lot, and then when there's some, people are moving less, which means const percent movement equals 100 divided by, social distancing divided by 100 divided by 100, and we go from random uniform minus, let's say the max movement is 4 pixels times percent movement. Oh, this is going to be minus 1 minus social distancing divided by 100, and then up to 4 times percent movement. So now when we have people who aren't socially distancing with a mortality rate of 4% and a virality of 50% and 40 steps length of infection, everything dies, because what happened here? Social distancing was wrong. Let's see, console log percent movement. What's gonna happen? Percent movement. Let's see. Start simulation. We got nan right away. What about if we pass in social distancing? Start simulation. Undefined. So that's the problem. Why is social distancing undefined? So let's see. Use population gets social distancing and passes it into people move. But is it not getting social distancing? Nope, it is not. Like that. Now it's gonna work. Well, I am starting to lose my voice, which probably means we should stop live coding soon. Okay, reload. Okay, so my browser window crashed, so I'm gonna open a new one. No, localhost. Come on, localhost 3000. Yes, no, what? Oh great, now Brave is no longer opening localhost. Fun. I don't know why it does this sometimes. It's like gets stuck in some weird way. You see my default tab isn't even opening. So I'm gonna open Chrome instead. Let's see, will Chrome come up? Oh, there we go. Quit, localhost 3000. Come on. No, maybe I should actually open Chrome. Localhost 3000. What is up with my computer right now? CPU 10%. That should be fine. I bought a new computer just so I could live code more and easier. No, Chrome, I quitted you. Okay, so let's see, start simulation. Woo! God damn, they're moving a lot, and it's making everything go really fast. Although it's interesting that they're not dying. I wonder why people are not dying. Let's make the max movement not 4 pixels, but 3 pixels. Where are we? People move. Default should be, let's make it 3 pixels, or should we make it 2 pixels? No, let's make it 3 pixels. So 3 pixels. Reload the page, come on. Okay, so let's do it with no social distancing. People are moving a lot and getting very quickly infected. Not sure why nobody is dying, but I think it's just because there's literally been, like, it's going too fast. So people literally haven't had time to die because it's moving, so because everyone's getting infected so quick. Nice. Now the next, what we can do is show how many iterations there have been, because I think that will be useful. People move, people collisions, infect population, use population. Okay, so when we get the elapsed time in iterate population, we should also set, let's see, set iteration count to elapsed time divided by 60 and math.floor like that. And we're gonna use state, so use state const iteration count set iteration count equals use state of 0. Oh, so Ultra Persona, I don't know why Periscope makes the stream really low quality. If you go on YouTube or on Twitch, it's going to have a higher quality, but I'm honestly not sure why Periscope makes it so low. I should also figure out some way of linking here so that people can see what's going on, or like people can see the other links that they can go watch the same stream on. Okay, so we have the iteration count. We now need to return it from the use population hook. Iteration count, population, iteration count. Come on, iteration count. And then we are going to show that down here. So if we are simulating, we show the population, and then we say if simulating, show the iterations as iteration count, otherwise we show null. Oh, this can be a paragraph actually, like this will be better. Okay, so Periscope is a crappy app, yes, but the nice thing about Periscope is that it allows you to watch my stream directly in Twitter, which is, I think, where a lot of people end up watching this stuff. So we show the iterations now, and also when we start set simulating to true, we should say set population, set iteration count to 0, just in case. Okay, now let's try this. Start simulation, shows us how many iterations there are. Sweet. Okay, and now everyone is... Why is nobody dying anymore? That's weird. So with this much movement, it makes people not die, even though they should start dying after 40. Interesting. So what if... So with 100% social distancing, then we should get them not moving at all and nobody else gets infected. So that's working. The question is, why are people not dying anymore? And if we put social distancing to, let's say, 25% and start the simulation, still going pretty fast. But if we put the social distancing to 75%, nice. Okay, so this is working. I'm not sure why people aren't dying after the iterations anymore. That's kind of weird, but it's working. I'm liking this. So the only other thing we need is to make sure, how can we make this more user-friendly? We can also, let's try squeezing people together some more. Should we try squeezing them together some more? Nah, this is fine. But I think we're done. This is the main thing I was trying to implement today. And then I need to write an article about it, embed these widgets in the article, and make sure that there's some guidance so that people understand what they're looking at, and so that we can compare data from Corona to the flu to HIV and to all of the other stuff. I think that makes sense. So I'm just not sure about the whole mortality thing. Oh, you know what we can do? We can actually filter people out once they die. I think I don't know who had that idea. Carlos Chiesaro had that idea. I think it's a good idea. So let's see. Length of infection. Oh, and actually, instead of elapsed time, we can now pass in the iteration count. And that's going to make our life easier. So people die or get better, iteration count. And infect people with elapsed time. That's fine. So iteration count, where are we? People die or get better, iteration count. Instead of elapsed time and all of that stuff, we can just go like this. If iteration count is more than length of infection, then you get better. And if your mortality divided by length of infection is blah, so with a little bit of social distancing and with a high mortality rate, let's make sure that we see people dying. Yeah, so mortality has stopped working. Why is recovering and dying not working anymore? People die or get better. Let's see, console log, mortality and length. So iteration count, length of infection, and I need to fix this part before we finish the stream, before we end the stream. So start simulation. Aha. So the last one, length of infection, is undefined. Why is length of infection undefined? Because use population gets length of infection. Are we passing it in? No, we're not. Obviously not. So length, now it's gonna work. We make it a very highly deadly, a very deadly virus, and people die. Sweet. Okay, now let's try taking them out of the population when they die. Start simulation, function, iterate population. Okay, so here's what I'm gonna do. I'm just gonna stop drawing them. So if you're dead, if dead, return null. Like that. And then if you're infected, you get a color and stuff. So when you're dead, we return null, so you're not rendered, but we have to make sure you're also not getting infected. So I mean, people who come into contact with somebody who's dead don't get infected. Battery died in my camera, so I'm gonna change that. All right. And then I'm gonna deploy this so people can try it out. And tomorrow I'm going to write an article about it. OBS. Is my face moving? My face isn't moving. You know. There isn't even my face. There we go. Okay. So one last thing, just making sure that dead people cannot infect you. Infect people. So if you are infected, contact keys, contacts map, population map, and actually, you know what we're gonna do? When you die, we're just gonna make it so you're not infected anymore, and that will solve the problem. So invisible dead people can't infect others. Okay, so now we're gonna see the population decline. And we should also here go to population down here, and instead of just length, let's make sure that we're only counting people who aren't dead. P.dead. All right. So let's make a little bit of social distancing, a high mortality rate, start simulation, and now when people die, they vanish. So that's good. We now have a working simulation. Nice. Sweet. Should we show, yes, we should show these values even when you aren't, So that, yeah, we need to make it easier to see what's going on. So here we're showing the iterations, but it would be nice if you could see what the values were. So instead of simulating or no, yeah, so we're gonna pass in whether we're simulating, like that. So slider, and we're gonna say editable is going to be whether we are not simulating right now. We're gonna pass that into every slider just so that we can, so that people can see what's going on even after they start the simulation, because I think that's gonna make it easier. Editable, and then we only show this if editable. We show this stuff, otherwise no. Okay, so start simulation. Cool. Nice. Okay, so we now have a working simulation. I'm gonna try to make this maybe a little prettier before I put it in an article. Should I even make it prettier? I think this is actually pretty good. But yeah, so if anyone has questions, ask away. I'm going to deploy this and share a link so you can try it out. Git status git commit -a-m. And then tomorrow I'm going to write an article about it, send it out to my mailing list and everywhere else that I can find. Git commit -a-m. Working interactive simulation, and I should probably put this on GitHub. Let's put it on GitHub. Let's deploy it with now new corona simulation, an experiment to simulate viral spread of COVID-19 under different conditions. Simulate viral of COVID-19 under different conditions. Yes. Create repository, set up and deploy. Yes. So deploy all of that under Swizzets. No. Okay, let's try again. It needs to be under React database because, you know, it's part of that project. Link to existing project, new. What's your project's name? Corona simulation. Let's do Corona simulation. Corona simulation. COVID-19, Corona simulation. In which directory is your code located? Yes. Setting up project. Let's see if that works. So kisses, that is a really good idea. We don't currently know whether people who recover from the virus are still susceptible or not, so I left it as yes, susceptible, but you're right, it would be cool if that was configurable as well. I should probably also let's make a little GIF of this just so I can share it with people. So record video. And now let's see. Record. Let's make it a little bigger so that it's more in line with how different things like to have. So it's more like that. Key, and record video, and we say social distancing is at 55%, mortality 4, length of infection, start simulation, and we can see how they spread. Sweet. And then if we don't, lol. Okay, so that was a fail. We're gonna try that again. Yarn start. Let's try that one again. Discard my recording, delete. So record video, bam. This is just so I can share it on Twitter. That's good enough. Record video. So we say with a little bit of social distancing, start simulation, and it spreads really quickly. You can see how fast it goes and gets everyone. And then we can restart that, and we say with a bunch of social distancing, we can see how much slower it spreads. Yay! Awesome. Lesson learned. Cool. So that's it from me for today. Oh, I said I was gonna share the link. So link is at coronasimulation.now.sh. You can try it out here. I'm gonna paste this into the chat room if anyone's still there. And thanks everyone for watching. I will see you again next Sunday. Until then, keep an eye out for an email and whatever else I'm gonna send out with this visualization. Thanks for watching.